Okay, so first thing I want to do is go through and I'll give you guys time to write this down now, or maybe you already have it written down. I just opened up the lesson plans for this week. You guys have access to this on Google Classroom. If you just go down a couple posts, you can see the lesson plans for today through Friday. So obviously we didn't have school yesterday because of President's Day. And so today, what we're going to be doing, if I can zoom in a little bit, today we're going to be, there we go, doing a circle worksheet. We're actually going to finish up our notes from Friday, and then we're going to do a circle worksheet. I am not going to do the lab with you guys today since we're not at school. So I may have time to do that later, or we may just not worry about it. But the circle worksheet is tonight's homework. Mrs. Price was actually going to meet with you guys today to go over your 8th grade schedules. You guys get to pick your encore classes for 8th grade. And so she has moved that to Friday. So the schedules, the 8th grade scheduling that you guys will do for next year will happen on Friday. If you're in person, it'll be during the end of the day during success time. And if you're a virtual student, you'll want to hang around after math class second period, and she's going to join right at the end of our second period math class on Friday and get you guys all the information you need if you're a virtual student. So, and I'll send you guys reminders of that. So we have the circle worksheet tonight. Then we're going to review for a couple days. I've got 2 different practice quizzes that we'll do. We'll do one tomorrow that'll be done in class. We'll do one Thursday, which is also done in class, which makes this circle worksheet your only homework for tonight, this week. Because on Friday we have a quiz, and that quiz is going to cover sections 8.1 through 8.4, which was circumference, area, and then perimeter and area of composite shapes. So that's what's going to be on Friday's quiz. So we'll go ahead and pick up where we started in the notes. Okay, see if I can get connected. Okay, let's see. All right. Can you guys see my iPad screen? Can someone confirm that before I go any farther?
Yes, sir.
Okay, excellent. Thank you. Okay, so on Friday, we were talking about the area of composite shapes. And so we split the shapes into these different figures into shapes that we do know how to take the area of. So we have triangles and rectangles and parallelograms, circles or semicircles, squares. I think for a lot of you, I did example D, but I don't think I got there for everybody. And so since it's been a few days anyways, I'm going to go ahead and start there. We'll do example D and E. I'll skip this circle one. We'll do our last example. And then I have a homework question that I'd like to look at from the 8.4 homework. Just a reminder that if you didn't see my post on Friday afternoon, the 8.3 homework that was supposed to be due today is actually, I gave you an extra day for that. So that's going to be due tomorrow. And this homework 8.4 is going to be due on Thursday. So there's nothing due today, no homework due today. You have all the time you need to finish up either one of these assignments, and let me know if you have any questions on the homework questions. So let's look at example D. Example D, we have 3 different shapes here, and I know a lot of you guys did this one already, but we have a triangle, we have a rectangle, and then we have a trapezoid. But I want to make sure everybody gets this example because we need to make sure we know how to use the trapezoid formula. Okay, so remember, if you go to your 8.3 notes, you have access to all these different formulas. You have the parallelograms and the triangles and the trapezoid and even the circle formulas there too. And so these are the formulas that I'm using for all of the questions on the 8.4 homework. So let's start with the triangle. The triangle formula is 1/2 times the base of the triangle times the height of the triangle. We know the base of the triangle is 4 inches. And then the height of the triangle, because it's tilted on its side, is going to be this 5 inches right here. And so I'm just going to do 4 times 5, which is 20, and half of that, which makes 10. So we have the area of our triangle, which is 10. The area of our rectangle, it's 9 inches for the length, 5 inches for the width. So 9 times 5, which is 45. And then for the trapezoid, its formula is the longest, but it's not necessarily the hardest. So it's 1/2. And then in parentheses, we put the sum of the two bases. And so for this trapezoid, we have one base being 9, the same as the rectangle. And then the other base is 6.4. And if you add those together, you'll get 15.4. So for a trapezoid, we just add the two bases together. And then for the height of the trapezoid, just like the height of all these shapes, it's 5 again. Okay, so I get my calculator out. 15.4 times 5 divided by 2 should give us 38.5. And then all I have to do now is what we did before, is just add those areas together. Add the area of the triangle with the rectangle with the trapezoid. So 38.5 plus 45 plus 10 should give us 93.5. And then I would label that in inches squared, because it's area, we have to use square units. There we go, get that out of the way. All right, now moving on to example E. Now this one's a little bit different from the rest. And all the other examples, you can see we were able to split the shapes into multiple parts and just add their areas together. And so for example E, what we have here is, if you think in terms of adding areas together, you're going to probably just split it right here and think, well, that's not really a shape I know how to find the area of. That's actually a 5-sided pentagon and a 5-sided pentagon, and we don't have a formula for that. And so the best way to do example E here is not to split it into multiple shapes, but think of it as a full shape. If that triangle piece right here, if that triangle piece wasn't missing, this would just be a full-size rectangle. Okay, and to find the area of that rectangle, I would do base times height, and the base is 13 meters and the height is 8 meters. So I would just do 13 times 8. That gave me the full area, which I know is going to be too much because they have a piece that's missing. But if we do 13 times 8, that gives us 104. Okay, so that's the area if the entire rectangle was there. But obviously, there's a part that's missing. So what I'm going to do is I'll find the area of this triangle piece that's missing. And instead of adding the areas, because it's not there, I'm going to subtract the areas. I'm going to take it away. And that's what makes this example a little bit different. So the formula for the area of a triangle is 1/2 times its base. Now this one is going to make us work a little bit. I know this is 4, and I know this is 4, and I know the whole thing is 8. So, or sorry, 13. 4 makes 8. So if the whole thing is 13, and I have 4 meters here and 4 meters there, then that makes 8. That must make this 5, because 4 plus 5 plus 4 would give us 13. And so the base of the triangle is 5. The height of the triangle, you can see here it's pointing is 6 meters. Okay, so times 6. 5 times 6 is 30, and half of 30 is going to be 15. So we're going to subtract these areas away, because this particular composite shape has a piece that's missing. And so that's why we're going to subtract. So 104 minus 15 is 89. 89 meters squared. Okay. So there are a couple problems. Actually, if I open up your homework from 8.4, there's a couple problems where you're going to have to do this. By the way, the 8.4 homework doesn't have a lot of questions on it, because you have to split these shapes into different parts. And so, you know, each shape has 2 or 3 parts you have to do. Looks like number 12 might have been the example we just did. So there's a homework problem. Number 13, for example, you can see that this is just a full size, if I can draw it better, a full size triangle with a rectangular chunk that's missing. Okay, so we'll have to do a triangle minus a rectangle. And then for this little guy here, this would be a, let's see, what kind of shape would this be? What kind of shape am I outlining?
A square.
A square, yeah, that's a square. So just find the area of a square and then subtract out the area of a semicircle. Okay, so that's what you would do for this one. Just like here, we're finding the area of a triangle and subtracting out the area of that rectangle. Okay, so there are some composite shapes where the best way to find the area is to subtract instead of trying to split it into shapes and then adding. Okay, so that's what I would do. And then we have this problem here in our homework. And I'm going to go ahead and go back to our notes because it'll save if I do it in the notes. And so I'm skipping this example. We're not going to worry about this one. Just don't have time for it because of the delay or the cancellation today. So I guess I'll do this problem real quick and then we'll get back to the homework. I forgot I had this one here. It says find the area of the pool and the deck. The figure is made up of a right triangle, a square, and a semicircle. Okay, so that makes this, if it says it's a right triangle, that must mean the right angle is right there. Okay, so we have a triangle. We have it says a square. And then we have a semicircle. Now, the reason it's saying semicircle and not a full circle is because part of that pool, half of the pool, is going to be accounted for when we find the area of that purple square. Okay, so we don't want to count that area twice. So let's start with that right triangle, which I highlighted in blue. Okay, the formula for a triangle is 1/2 times the base times the height of that triangle. And the base and height always meet at a right angle. So that right angle right here means that the 10 must be our base and the 24 must be our height, or maybe the 24 is our base and the 10 is our height. It really doesn't matter because I'm just going to multiply those two numbers together and then divide it by 2 because it's a triangle. In fact, I don't even have to use my calculator for this. If I do half of 24, I think most of you would tell me that's just 12, and 10 times 12 would be 120. Or you can use your calculator, you should still get 120 either way. Then for the area of our square is a 26 by 26 foot square. So we're going to do 26 times 26. Or 26 squared. And that's 676. So most of our area is coming from that. So so far we've included this triangle. We have its area. We've got the area of the square, which includes half of the pool. So we're only going to do a semicircle for the last part. And so the area of a semicircle is just half the area of a full circle. And the full circle would be pi r squared, which means pi times the radius squared. Well, 26 is not the radius of our circle. 26 is the diameter. Can someone tell me what the radius of our circle would be if I just did half of that?
13.
13, excellent, nice job. So we're gonna use 13 as our radius and we're gonna square it. And then we're gonna divide it all by 2. That's what the half means because it's only half a circle. So 13 times 13 times 3.14, 530.66, but we're going to divide that by 2 because it's a semicircle, and that's going to give us 265.33. If you're using the pi button, you're going to get something a little bit different from that. And then we can add that with the square, which was 676. We can add that with the triangle, that was 120. And if I did it right, which I'm using my phone calculator, so I can't tell if I had a typo, maybe someone can double check my work, but I'm getting 1061.33. And then because it's area, that would be feet squared. Okay, so this is one where, again, instead of subtracting, we're just going to add the areas together. So sometimes it's easier to add the different shapes together. Sometimes if there's a chunk that's missing, it's better to subtract an area away. Okay. But we're just using the formulas that you guys have used for a couple years now. And if you don't remember using them, that's why I wrote them down in those 8.3 notes, so you can still use them. All right, now we're to number 16. Number 16 says the fountain is made up of 2 semicircles and a quarter circle. Find the perimeter and the area of the fountain. Round the perimeter to the nearest tenth, but round the area to the nearest square foot. Okay, so it says 2 semicircles and a quarter circle. So I've got my 2 semicircles here. And then this piece here is a quarter circle because it's only 90 degrees. And so if it were a full circle, it would look like this. And so that's only 1/4 of one. So there's the quarter circle, okay? Now, we're gonna start by finding the perimeter. Okay, so for the perimeter, I gotta think, how many sides do I have? And this one's gonna be kind of confusing because they're all curved sides. But I have a side here, I have a side here, and I have a side there. So I really have 3 different sides I'm gonna find for the perimeter. Now, fortunately, these 2 guys here have the same perimeter because those semicircles are the exact same size, okay? So I'm going to erase everything just so you know what I'm finding right now. I am only finding the perimeter of these 2 semicircles right now. So I'll stop right there. Okay. All right. So the circumference formula is what we're going to have to use here because the circumference formula gives us the distance around a circle. And so the circumference formula is pi times diameter. Now, for semicircles, we would have to divide that by 2. But we have 2 semicircles here. And so we talked about all week long how 2 semicircles just makes 1 full circle. So I'm not going to divide it by 2. I'm just going to treat it like it's 1 full circle. And the diameter of the semicircle is 20 feet. 20 feet is the distance from one side all the way through the other side. So pi times 20 is going to give me the circumference of what I've just drawn in red here, which is this chunk here, okay? And so pi times 20 is 62.8, whoops, 62.8. That's how far it would be if I were to walk around the fountain from the part that's there, that's in red right there, the 2 semicircles. Now I have to do the quarter circle part. So I'm going to add this part on. Now, if a semicircle is half a circle, I would take half of a regular circle. A quarter circle is just going to be 1/4 of a circle. And so I'm going to, let me scoot this over a little bit. Oops, let me move you over here so I can remember, there you are. Okay, so now I'm going to add that with a quarter circle, which is going to be 1/4 of the circumference formula. And so the circumference formula again is pi times diameter. Now here's the issue here. With my quarter circle that I drew, the 20 feet is no longer the diameter. The 20 feet is the diameter of the red semicircles, but 20 feet is not the diameter of the purple circle, it's the radius. And so if 20 feet is the radius of the purple circle, if I go all the way through it, that'd be another 20, and that would make its diameter 40. Okay, so it has a different diameter than what the semicircles do. But because I'm doing 1/4 of that, I might as well apply that right now. 1/4 of 40 is the same as saying 40 divided by 4, and 1/4 of 40 is just going to be 10. So this is actually just the same as 10 pi. If I combine the 1/4 and the 40 together, and 10 pi, 10 times pi is going to be 31.4. Makes sense. I just moved the decimal over 1 spot from where it was when I used pi. So I'm going to add those 2 together, 31.4 and 62.8, and that's going to give me a total circumference of 94.2. And that would be in feet. And that's the answer that's going to go right. Oops, don't want to move that. That's the answer that's going to go right here. 94.2. And it does want us to round that answer into the nearest 10th, and we have it to the nearest 10th, so we're good. All right, so that's the perimeter. Now for the area. The area uses a different formula. It uses the formula pi r squared. Oops. If I can write it. There we go. So let's go back to our two semicircles then. This time I'm doing the space inside of them. That's the area, right? And so because they're two semicircles, again, they make a full circle. So I'm not going to split my area formula in two. I'm going to use it as one full formula because if I just combine those two semicircles, I get a full circle. So pi times the radius. Now, I'm going to erase the purple for a second. The diameter of the semicircle was 20, but the radius of the semicircle is going to be half of that. Can someone tell me what half of 20 is?
10.
Good. So the radius of our two semicircles is going to be 10. So pi times 10 squared, using my area formula, because I have to use the radius when I'm finding area. And so 10 times 10 is 100, and 100 times 3.14 is just going to be 314. Move the decimal over twice. So that's the area of both of the semicircles. We have got this part right now, and now we need the area of our quarter circle, which again, let me draw that real quick. It's going to look something like that, and the quarter circle is just going to be this chunk right here. Okay. Now, last time we had to use 40 for the diameter of the purple circle, but the radius we said was 20, and the radius is exactly what I want to use this time. So I'm going to again do 1/4, because it's a fourth of a circle, times pi radius, which is 20 feet squared. Okay, and I'm doing a fourth of that because it's not the full circle. I only want this chunk of it. So 20 times 20 is 400. Which makes this kind of easy because 1/4 of 400 is just 100. And 100 times pi is exactly what we did when we did 10 squared times pi. And so that's going to give us 314 again. So I'm going to add what's interesting is the quarter circle has the same area as the two semicircles combined. And so I'm going to add 314 with 314, and that's going to give me, I'm going to add these areas together. That's going to give me 628 feet squared. Because it's area, I have to use square feet. And that is what's going to go right in the second box here, 628 feet squared. Okay. So I'm going to leave this one in the notes. In fact, as soon as this says that it's done backing up, it will be saved. And so what you guys can do is you can go to Google Classroom to Friday when we were doing 8.4. If you want, you can re-download these notes and have my version of the notes if you didn't get it all copied down. But I wanted to spend our last little chunk of time going over tonight's homework. So 8.2, the perimeter of composite figures. This 8.2 is due tomorrow. I gave you an extra day on that one. 8.4 is due Thursday. I gave you an extra day on that one as well. Okay. And then this homework, this circle worksheet, is also going to be due Thursday. You have 2 full days from right now to do the circle worksheet. And this is what I attached to your e-learning. So if you go to Google Classroom, you have a digital copy of this worksheet. It says it has 9 problems on it, but I've cut a couple of them off. But we only have 1, 2, 3, 4, 5, 6, 7 problems. Now, for number 1 and number 2, you'll have to be careful because if you read the instructions, you actually have to find the circumference of the circle and you have to find the area of the circle. So you have to have 2 parts. You have to find the circumference, which the circumference formula uses the diameter times pi. And the area formula uses the radius squared times pi. Okay, so you'll want to do that for both circles. For number 3 and number 5, we did problems like this in our last, it was the circumference and area worksheet. So I'm not going to do number 1 and number 2 because you should be good on that, but I will look here at 3 and 5. Shrink my font size down a little bit. For number 3, it wants us to find the radius, and so it gives us the circumference. So here's my circumference formula, C equals pi times d. Instead of plugging in for the diameter, they tell me that C equals 36 pi. So remember how we did this on our worksheet last week? We plugged 36 pi right in underneath the C instead of underneath the diameter. And then can someone explain to me, what did we have to do to get the diameter by itself? We had to work backwards.
Divide.
Divide, yeah, nice job. So we're just gonna divide that pi away. And because they wrote their circumference in terms of pi, dividing by pi also divides that pi away. And so I'm left with the diameter equals 36. Now on the last worksheet, they asked us to find the diameter. This time they want us to find the radius. And since we know the radius is half of the diameter, we can just divide that by 2. And 36 divided by 2 is 18. So the diameter here would be 18 centimeters. I'm sorry, not the diameter, the radius. The radius would be 18 centimeters. Okay, now the area one is slightly more complicated because the area formula is slightly more complicated. The area formula is pi r squared. So because they tell us the area is 121 pi, instead of plugging in for r, we'll plug that in for a, for area, and we're going to write 121 pi right here underneath the a. And then just like last time, I think Catherine said it, we're just going to divide both sides by pi because we're going to have to work backwards here. And when you divide the right side by pi, pi symbol goes away. When you divide the left side by pi, the pi symbol goes away. Okay, so I'm looking for my radius. I know that the radius squared is 121. So can you guys think of a number that when you times it by itself gives you 121?
11.
Nice job, Cadence. Yeah, it's 11. It's 11. So if you didn't know that it was 11, we actually have a button on our calculator to help with that. It's called the square root button. If you do 121 and then take the square root of it, it would just tell you that it's 11 because the square root tells you what number you had to times by yourself. But yeah, 11 times 11. Nice job. So the radius here is going to be 11, which that is our answer because it asked for the radius. So 11 centimeters. Nice job. So a little bit more work on that one. Now, the last 3 questions on the worksheet are all, I guess you could say that they're kind of composite shapes, right? They all have to do with circles though. No trapezoids, no triangles. I do see a square at least to number 7. So it wants us to find the area of the shaded part of this worksheet. Sorry, the shaded part of the shape here. So for number 7, the shaded part here is everything that's in gray. And so I want you to think that would be a full circle if this square piece hadn't been removed. So let's treat it like it's a full circle. Let's find the area of that full size circle. And the area formula is pi times the radius squared. Now, the reason that they're setting that circle inside of a square is because the dimensions of that square help us find the dimensions of the circle. The side length of each of those squares is 12. That means if I were to draw a line right through the middle of my circle, that dotted line that I'm drawing is going to be 12. That dotted line represents the diameter of my circle because it goes all the way through. So if my diameter is 12, what would that make my radius?
6.
6, yeah, be exactly half of that. Good. So I'm going to do pi times 6 squared. That's going to give me this full circle. But I don't want the full circle. There's a part of the circle that I would like to remove. And the part of the circle that I'd like to remove is this square piece right here. So I'm just going to subtract away the area of that square piece, which is 4 times 4. Who can tell me what 4 times 4 is?
16.
16, good. So the area of that little square is 16. So I'm gonna let you guys finish this one. Find pi r squared and then subtract away 16 from it. And you'll have your area of this shaded in portion of a circle. When you get your answer, it does want you to round to the nearest 10th. So 1 decimal place instead of 2. I think they ask you to do the same thing up here for numbers 1 and 2. Yeah, they say nearest 10th. Okay, let's look at number 8. Number 8, we're supposed to find the area of this shaded part, which the shaded part makes a full-sized circle. So why are they giving us this other circle? Because if we look at the part of the circle we want, they don't give us the radius or the diameter of that circle. And so we're going to have to use the other circle. So because the other circle has a radius of 16, I know that if I draw this dotted line right here, that dotted line is going to be 16 as well, because that dotted line I just drew is the radius just going the other way of the big circle. The radius of the big circle happens to be the diameter of the small circle. And if it has a diameter of 16, I only want the radius because I'm finding area. So what is that length of that red line right there? If the diameter is 16, what's the radius?
8.
Good job. Yep, good job. So I'm just going to do pi r squared. And now that I know that the radius of that small circle is 8, that's all I have to do. I don't have to add anything. I don't have to subtract anything. That'll give me the area of that full circle right there, just the tiny one. So I'll let you guys give the answer for that one. Again, you can do that on your own. And then number 9, much like our homework question we looked at, number 9, the portion of the circle that's shaded in here is just a quarter circle. So do the area of a full-sized circle, but then divide your answer by 4, or take a fourth of it. I'd probably just divide it by 4. That'd be the easiest thing to do. So for number 9, they give you the radius. They tell you that it's 10. So I'm not going to write r. I'm going to write 10 for r, for the radius. So pi times 10 squared would give you the full circle. If you divide that by 4, divide that final answer by 4, and you'll only get the quarter circle part that you want right there. Okay, so you can finish 7, 8, and 9. I've helped you quite a bit on 7, 8, and 9. We did 3 and 5 together. The only problems I didn't do are our normal circle ones, where you have to find the circumference of both. You might even want to just draw like a line right through the middle of the problem, so you know that there's 2 parts. You have to find the circumference on one side, area on the other side of these 2 circles. That's really all you have to do that's left, other than find the answer for 7, 8, and 9. That is tonight's homework worksheet, and this is due Wednesday. Don't forget that we've got 8.2 and 8.4 big ideas homework that's due. 8.2 due tomorrow, 8.4 that's due Thursday. And guys, please email me if you're stuck on any of them. I'm free all day today. It's e-learning day, which means I'm home, but I'm also home to help you guys. And so if you guys are stuck on something, please let me know. And I will hopefully see you guys back in class tomorrow. Fingers crossed for a 2-hour delay. I'd rather have a 2-hour delay than an e-learning day. I don't know about you, but we'll see how that goes. Okay, so I'll see you guys later. Let me know if you have any questions. Bye, guys.